Hello everybody, welcome into another lesson. So today we are going to talk about transformations by reflection. So you can reflect, in this lesson we're going to talk about how you can reflect shapes which are made up of coordinates over the x-axis or the y-axis. In other courses, there's other ways you can reflect it. You can reflect it across a line at the origin, at y equals x, and so on. But in this course, we're only going to talk about reflecting across the x-axis and the y-axis. So when you reflect across the x-axis, which goes from left to right, the x-axis, that's what's called your line of symmetry. That's the line that's being reflected over. That's all a line of symmetry is a line that points are being reflected over. So here we have triangle ABC. We want to take that triangle and reflect it across the x-axis. In order to do that, you got to leave your x coordinates alone. You take your y coordinate of each one, you multiply it by -1. But first, let's list our actual coordinates of the actual triangle. So A has the coordinate -2, 3. B has the coordinate -6, 4. C has the coordinate -4, 8. So we got our coordinates A at -2, 3, B at -6, 4, and C at -4, 8. We want to take these coordinates and reflect them over the x-axis. How you remember it is, when you reflect something over the x-axis, you leave your x-coordinate alone, and you multiply your y-coordinate by -1. So whatever axis you reflect it over, the opposite coordinate gets multiplied by -1. That's a good way to remember it. So let's start with our first coordinate, -2, 3. Well, we want to reflect that across the x-axis. In order to do that, you leave your -2 alone for your x, but for your y, you're going to take 3 times -1, which would have to mean that coordinate A becomes A prime. A prime, again, is your transformed coordinate. If you remember from the last lesson when we did transformations by shifting, it's the same idea with reflections. You call the transformed coordinate prime. It has that tick mark beside it. So A prime, for the x coordinate being left alone, -2, it'll stay -2. But your y coordinate, 3 times -1, becomes -3. So A prime is located at -2, -3. And we can plot that point right here. That's going to be our A prime. All right, let's do coordinate B. So again, since we're reflecting across the x-axis, leave your x-coordinate of -6 alone. But you're going to take your y-coordinate of 4, you're going to multiply that by a -1, which means that B prime, well, that's going to be your x-coordinate -6 was left alone, but 4 times -1 for y, that becomes -4. So B prime is going to be -6, -4. So 2, 3, 4, 5, 6. Right about there. Right about there would be... that would be our B prime. Okay? And last but not least, we need to find C prime. So let's take C. Take our C coordinate. We will take -4 of the x-coordinate, we'll leave that alone, but take your 8 for the y-coordinate, multiply that by -1. That gives you C prime is going to be, for your x-coordinate, -4 was left alone. Your y-coordinate, 8 times -1, that's -8. So your C prime coordinate is -4, -8. So that's -4, -4, 5, 6, 7, 8. Right about there. That is our C prime coordinate. So what you get when you reflect, you get two congruent figures. I know it doesn't look drawn to scale the best, and I'm sorry because I probably didn't draw my coordinate plane the best, but you get two congruent figures that are reflected over this line of symmetry, over the x-axis. It kind of acts like a mirror. Think of looking at something in a mirror, everything looks backwards. Well, that's kind of what you get here, and when you reflect something across an axis, across the x-axis, you get the mirror image. So that's because all your y-coordinates went negative. That's why. But that's the end result here. You get triangle A prime, B prime, C prime after you've multiplied your y-coordinates by -1. Help if I got an eraser. And I do have more examples here. I got plenty more. Alright, let's draw another coordinate plane. Alright, go up. Just bear with me while I draw this nice coordinate plane. Again, for today's purposes, I think we'll stick with triangles. You can, of course, use quadrilaterals. You could use polygons of any type. You can use all kinds of shapes to reflect. But I think triangles are probably the easiest to work with. So we're just going to stick with that. Almost done here. Just got to make sure I have sufficient points for the coordinate plane on each axis. Alright. Let's say here we got 3, 3. That'll be A. 5, 5. That'll be B. Then 7, 2. Alright. So we got another triangle here. We have triangle ABC. We want to reflect this across the x-axis. We want to do it across the x-axis. So, what we got to do again, before you do any changes in your coordinates, before you do anything like that, you list your original coordinates. So, coordinate A has a coordinate of 3, 3. Coordinate B has a coordinate of 5, 5. And then coordinate C has a coordinate of 7, 2. Okay? So now we've identified our original coordinates, A being 3, 3, B being 5, 5, C being 7, 2. we want to take each of these coordinates, we want to reflect them across the x-axis. The x-axis is our line of symmetry, or our mirror, if you will. So remember, when you reflect something across the x-axis, what you got to do is you leave your x-coordinate alone, but you multiply your y-coordinate by -1. So let's start with that 3, 3 coordinate for A. You'll leave your x-coordinate of 3 alone, but you'll take your y-coordinate of 3, you'll multiply that by -1. So that means your A prime, your transformed A coordinate, your x-coordinate's 3, your y-coordinate is 3 times -1, that become -3. So A prime is 3, -3. Right there. That's our A prime right there. Alright, let's look at B. Let's look at 5, 5. So again, you leave your x-coordinate alone, but you'll take that y-coordinate of 5, you're going to multiply that by -1. Okay, so that means your B prime coordinate is that x being 5 being left alone, but that y-coordinate is 5 times -1. Well, guess what? That's going to be -5. So B prime is 5, -5. 5, that's 3, 4, 5. That's going to be B prime. Last but not least, we need to figure out C prime. So we take that coordinate of 7, 2. The x-coordinate 7, we leave that alone. But you take your y-coordinate of 2, you're going to multiply that by -1. Which would have to mean that C prime is going to have the x-coordinate of 7, that's left alone, but your y-coordinate is 2 times -1, that'd be -2. So C prime is at 7, -2. 5, 6. 7, -2, right about there. So that's going to be C prime right here. And you see what we get. You get a nice reflection across the x-axis once you've connected your points. You get congruent triangles. They're congruent because the sides all have the exact same length. They're just simply reflected. It looks distorted. It's reflected. It's going to, since it's a reflection. But you got two congruent triangles here. You have triangle ABC being the original. And then once you've done the transformation by reflection, you have triangle A prime, B prime, C prime. So that's what you get when you reflect across the x-axis. Now, we're going to change it up a bit. We're going to do the y-axis. We're going to change the axis we're using to reflect. As a matter of fact, I'm even going to keep the same triangle, but I'm going to show you how it works when we reflect in the y-axis. Alright, so let me change up here. So far we've done the x-axis where you leave your x-coordinate alone, you multiply your y-coordinate by -1. Well, when you reflect in the y-axis, it's the opposite. You leave your y-coordinate alone, you multiply your x-coordinate by -1. So the line of symmetry, when you reflect in the y-axis going up and down, that is your line of symmetry. So let's go ahead here. Again, when you reflect across the y-axis, leave your y-coordinate alone, multiply the x-coordinate by -1. So it's the opposite of reflecting it in the other axis. Your line of symmetry becomes the y-axis. That becomes your mirror. So, like you would from before, you're going to list your original coordinates. A was at 3, 3. B was at 5, 5. and C was at 7, 2. Okay, so we've listed our original coordinates. Now we need to find A prime, B prime, and C prime. Let's start with A. When you reflect across the y-axis, you take your x-coordinate. So that x-coordinate of 3, you're going to multiply that by -1. You're going to leave your y-coordinate of 3 alone, which means that A prime is going to be, since you have x being 3 times -1, that'll be -3. Your y was left alone, that would just be 3. So your A prime is -3, 3, which would be right there. That is your A prime at -3, 3. Okay, let's deal with B now. So you take your x-coordinate of 5, you're going to multiply that by -1. You're going to leave your y-coordinate of 5 alone. So B prime for the x is 5 times -1. That'd be -5. Your y left alone being 5. So B prime is -5, 5. So 3, 4, 5. 3, 4, 5. Right about there. That is your B prime. Okay. Last but not least, we have to do C. So C, in order to get C prime, we're going to take our x-coordinate of 7, we're going to multiply that by -1. You're going to leave your y-coordinate of 2 alone. So that means that C prime has to be 7 times -1 for your x. That'd just be -7. And then y, the y-coordinate was 2. That was left alone. So you would get -7, 2. 2, 3, 4, 5, 6, 7, 2. So that's my C prime. And wouldn't you know it, ladies and gentlemen, we have a nice reflection here. It looks like a nice reflection across the y-axis. So you got a triangle now, A prime, B prime, C prime. So once again, when you reflect across the y-axis, you leave your y-coordinate alone. You take your x-coordinate, you multiply that by -1, and that's how you get your new transformed shape with your transformed coordinates. And I'll do one more example here of across the y-axis. I think I'm really going to mix it up a bit though. I think I'm really going to. You know what? Let's do something interesting here. So let's see. We'll have the points 0, 2, 0, 5, that'll be point A, this will be point B, and then we'll do 3, 4, we'll do 4, 3. Alright, so we have a triangle. We got some points right on the axis. This is actually about to look pretty cool here. You're about to get a nice cool reflection. It's going to be truly symmetric. Not that the other ones weren't symmetric, but you're going to see how this can work sometimes. So we have triangle ABC. Again, we want to reflect this across the y-axis. That is our line of symmetry, is this y-axis going up and down. So what you're going to do, once again, before you do anything, list your original coordinates of the points. So coordinate A is going to be at 0, 2. Coordinate A is at 0, 2. Coordinate B, 3, 4, 5. It's at 0, 5. And then coordinate C is at negative 4, 3. So coordinate C is at negative 4, 3. Alright, so we've identified our original coordinates. Since we are reflecting this across the y-axis, what we have to do, you leave all your y-coordinates alone. You don't multiply those by anything. You leave them alone, but you take all your x-coordinates, you multiply your x-coordinates by negative 1. So let's start with point A, 0, 2. You'll take that 0, you'll multiply that by negative 1. You'll leave your y-coordinate of 2 alone. So that means that A prime, if you multiply 0 by negative 1 for your x, that would just be 0 still. Your y-coordinate was left alone, that is 0, 2. Very interesting. 0, 2 is also A prime, which does happen. You can get that. 0, 2 is both A and A prime. Alright, how about B? So you take the 0, 5, you'll take your x-coordinate of 0, you'll multiply that by negative 1, but you leave your y-coordinate of 5 alone, which means that B prime, since you have an x-coordinate of 0 times negative 1, that's just 0 still. Your y-coordinate was left alone, that is 5. Also interesting, B prime is 0, 5. So B and B prime are both located at 0, 5. How about C? What's going to happen with C? So again, you'll take your x-coordinate here, negative 4. You're going to multiply that negative 4 by negative 1. But you're going to leave your y-coordinate of 3 alone. You don't do anything with that. So that means your C prime, your x-coordinate, negative 4 times negative 1, that turns into positive 4. Your y-coordinate, 3, was left alone, so your C prime is at 4, 3. So let's find 4, 3 right there. Located C prime, we've drawn the triangle shapes, and you've got two symmetric triangles side by side right on the line of symmetry. You can have that where there's overlap, where it looks like they overlap and touch. You will get that sometimes. If you have points right on the axis, you can expect to have what looks like overlap or where they touch. It looks like literally you could take these two triangles, fold them in half, and make one triangle. I think that's kind of cool. But remember, whenever you have a reflection, you want to reflect in the y-axis, you leave your y-coordinates alone, but you're going to multiply the x-coordinate by negative 1 to get your transformed coordinate. If we were reflecting in the x-axis, you would leave your x-coordinate alone. You'd multiply your y-coordinate by negative 1. And then you would, if you were reflecting in the x-axis, it would have been somewhere down here instead. It would have been down there. But that's really it for reflections. There really isn't much to them. Just remember, again, this is the y-axis we're reflected in. So whatever axis it is, whatever axis you're reflecting it on, you leave that coordinate alone. And then you multiply the opposite coordinate, the other coordinate, by negative 1. So you reflect in the y-axis, leave your y-coordinate alone, multiply the x by negative 1. And if you're reflecting in the x-axis, it's the other way around. So that's it for this lesson. Next lesson we will do our last transformations unit, transformations lesson on dilations and shrinks. Those will definitely be different. So I hope everyone has a good night. Take care.